now the key question will be, when I design the lesson, what is quality classroom assessment? Again, based on Stevens, he emphasized that we need to be very clear of our purpose. Clear purpose, is it for, you want to find out at this period of time how much have the students learned? Right? Or is it that you want to inform certain kind of instructions? How is my teaching? How are my students taking to my teaching? Right? Who will use the results? When you say who will use the results, not so much of reporting. It's more of how this result can inform me so that I can change my practice to help the students close the learning gap or to advance their learning. It's not always just really to close the learning gap. Sometimes if you are taking a class that are good, we should also be thinking how could we promote, stretch their students' thinking, or how do we help the children to be able to assess maths even at a higher level. Okay. Then, clear targets. What is it precisely are we assessing? What are the learning targets? Are my students very clear about what is it that they need to learn during this lesson, in this lesson? And this will determine what the strategies that I use. And that's where the design is. What method? It's not because I like concept cartoon. It's why am I using concept cartoon for the lesson? Is concept cartoon the best way to surface my students' misconception? Or could it be a short quiz might be more effective? Sometimes a short quiz, 5 questions, but tells you a lot of things, easy to implement, doesn't take up a lot of time, but it can be just as effective. Or could it be another strategy that is more effective? That is where, when you are clear about the targets, then what is the assessment strategies that we want to employ, what method we want to use to give us the information that we need to inform our teaching so as to help our students learn. Okay. Then, of course, how can we get our students involved in the assessment? Students involved, when students are involved, there's a greater ownership. Right? So, with this, let me give you a rough idea of what is learning targets. Learning targets basically are students' learning description, words, pictures, actions, or some combination of it, or what you intend students to learn or accomplish in a given lesson. Let me give you an example. Let us say P2. You want your children to be able to use model to illustrate number sentence. So on that day, your student will be clear. When I have 2 plus 3 equals to 5, I can use one, you call that a bar, or you call it a box. Okay, this box will represent 2. This box will represent 3. If I put them together, this will form 5, and this will represent the whole. So the children are very clear that I'm using models to represent my addition equation. Not because I must draw model. It's more of children understanding why am I doing this and what is the ability that I need to have. Which means to say I must be able to translate the number equation into a diagram form. And this is a skill. Okay? The clarity needs to be there. Or if I'm teaching fractions, for this lesson, I want my children to be able to tell me that a fractional part will show how the whole has been equally divided into. So for example, if it's 1/4, I'm able to tell you that the whole has been divided into 4 equal parts, and 1 part is 1/4. And that's why I say 1 out of 4. So there are certain words that the teacher is very clear what I want to hear my children say. I want my children to tell me it's 1 out of 4 equal parts. I want to hear my children to be able to say the whole has been divided into 4 equal parts. And I'm talking about 1 part out of 4 parts. And that's why it's written as 1/4. So the actual target that the student can see and direct the effort forward. So if you are very clear about what is the target, when the If the children say that I don't understand, they are also clear what is it that they don't understand, rather than you say I don't understand fraction. You must know what is it that I don't understand, or what is it my student have yet to understand. Then it's easier for you to remediate. Okay? So, idea is to plan, to monitor, and to assess. Basically, in terms of learning targets, according to this book, okay, I forgot the author. I was saying the author. I'll go to write down. Knowledge, reasoning, products, and performance. So, learning targets can be informed of, is it the knowledge you're interested in? So, based on our framework, the knowledge could be your skills and concepts. Reasoning target could be your processes. And products and performance could be any of this. Something that you want the student to do in order to demonstrate your mathematics understanding. Right? So, I have pulled it out. I put the examples from our teaching and learning guide, the 2017 learning guides. Right? For example, knowledge targets. I will ask students to know and understand specific content related to a learning target. And in knowledge target, it's always identified by the verbs, identify, describe, name. And this is very is already spelled out in the learning experiences. If you look at the teaching and learning guides, have you seen the teaching and learning guides? It's good to take a look. I know your P3 and 4, you have yet to reach there. Yours will be P3, for P3 will be 2015, P4 is 2016. However, I'm going to take a look at what is it that is expected, right? In fact, it's not new, but when they introduce learning experiences, they are making it more precise. What processes that your children need to go through in order to learn that concept. Although it's not implemented yet for a level, but it's good to take a look. It's relevant, okay? It's making it more explicit. What is it that children must do? Just like you told me, right? Do, think, do, say, read, write. What is it that children must do in order to learn that concept? So like, for example, knowledge target, it could be the children able to make a list of first 8 equivalent fractions of a given fraction. Or it could be able to recognize and describe 3D shapes found in the environment. It's more targeted at the knowledge. Then reasoning is more of concept, right? By explaining, putting in your words, and able to justify why is this an example of a fraction, why is this not an example of a fraction. Okay. So one of the examples could be compare two unique fractions. They compare, but this could be just knowledge only. But if they are able to explain why the greater the denominator, the smaller the unique fractions, they would be, you'll be able to show you that they actually understood. Okay. Performance target. I think this is not new. So I think some of you may have done this before. Able to we ask the student to do survey and then to construct a graph of the survey. This is a product. It could be a performance task, right? Okay, it can fall under the performance task. Okay, any question at this point? The reason why I have introduced learning targets is to provide greater clarity of the objectives. In our syllabus, we talk about objectives, right? However, objectives will take, I'm not saying it's no, we still need objectives, but we need to take the concept further to be more specific, so that when we design a lesson, we are clearer what is it that we want our children to achieve. And when we design lesson, it does not mean that we only have one target, we could be 2 targets. What is the targets that we want to achieve in this lesson? With this clarity, I feel that when teachers observe during the research lesson, when we have conversation, it's also easier for us to discuss, to be more precise as to what is it that we want to see our children do, or what is it that we have not, the children have not done. For example, if you give the children fraction list to compare unique fractions, you are very clear what is the learning target. Then when we observe, you will observe what is the children doing. compare? The children can be putting two fractional part aside. Is this comparing? Then, when we discuss, when we give feedback, it will be more descriptive, more precise, and then say, oh yeah, perhaps they are not even clear as what do I mean by compare. They may, because their action shows that when you compare, you must mesh them, right? Put them either side by side. I mean, one on top of the other, one on top of the other to see the size, or one just below the other to compare, not apart. So the target that we want to achieve for lessons need to be very, very precise. And if you are engaged, you want the children to engage in self-assessment, the children also need to be very clear what is it that I need to achieve. What is it that I must be able to do? What are the things I must be able to do in order to show that I have mastered certain things? So the precision is important. Clarity of the objectives.
Sorry, what about learning outcomes? What you want to achieve? What the students should be able to do at the end of the lesson?
Okay, there's a terminology. In PLC, we talk about learning outcome. Right? In learning outcome, if you were to look at the definition, it's not just only the lesson content itself. It could be the outcome, you want the children to be self-directed learners. And self-directed learners may not be achieved in one lesson.
So it's broader.
Yes. Learning outcome. Learning outcome, students' outcome is broader and it will take a longer time to achieve. Whereas learning target is very specific to this lesson. You may need many learning targets to achieve one learning outcome. That's a very good question. Yeah. Same like learning objectives. I want the children to be able to solve two-step problems involving fractions. These objectives sometimes will take a few lessons to achieve. However, we need to further break it into different smaller parts so that we are clearer that they're able to achieve this target before you move on. It's a progression. Yeah. Okay, thanks for the question. Any more questions? Okay. If there's no question, let me share with you a video of a lesson that the teacher used questioning, right, to help the students self-correct, to enable the students to self-correct, and to provide feedback as to where the students have got it wrong, so that the child can self-correct. He has used a strategy called top moves. Right? Top moves, there are 5 aspects to top moves. Right? One is revoicing. Revoicing is, it looks like paraphrasing, but it's not paraphrasing. In revoicing, you make the students' responses, you articulate the students' responses in a more comprehensible way for everybody to hear, and also for the students who have responded to you to be clearer in their thinking. And you also want to give the children back the ownership by saying, is that right? Is that what you mean? Because when the student answers the question and it's not clear, and you say it like this, right, in a good way, and if you don't go back to the student and say, is that what you mean? And so on. The children will feel that, oh yeah, now I don't have ownership to the question. By saying that, you acknowledge, you affirm the person, and at the same time, you give the person opportunity. So that is all revoicing. And then use some great time, and of course, adding on, get the classmate to add on to the responses, and to repeat, even classmate repeating also here. At the same time, while you are addressing this person's misconception, you are also asking, trying to pick up how our other students, have they had the same problem, or what other problem does the child has. Okay, so you watch this short video for assessment for learning impression. Usually when we use I think this is a common practice. We ask the student to use whiteboard to write down the responses. Then after that, flash show the answer. Good practice. You can see how many people got it right, how many got it wrong. So after that, what do you do? What's the next step? Usually, the usual practice, okay, is that the teacher explain the answer. Right. Okay, get the student to explain. Okay, get the student explain the answer, and then after that, we close, more or less move on to the next question. Right? Is that the
those who get to make mistakes, you also have to point that out.
Okay.
Those who make mistakes, so get them to explain why they did it.
Okay, good.
They get it.
Yeah. Okay, that is very advanced practice. Yeah. In this particular lesson, right, I was his mentor for one of the project. Now, his practice was children give the answer. Right. After that, he will explain. And sometimes he asks the student to explain. After that, he will talk. Right. And usually it's a clear answer. He will not pick on the misconception. Students' errors and mistakes are actually very rich resource for you to use. Right? So I taught him a strategy, and it's very good. This is his first attempt, and he did very well. Okay. So later he asked by looking at the students' responses, he picked up only one. Alright. Another person also did get it right. He picked up this particular person, and then listen to how he has asked for the question so that the child will self-correct.
How do you get 13? There's 34, right? All of you need to listen to Lila mention that 34 plus 4 is, okay, that's subtraction 2 plus 2 is equal to 12, right? And then she added one more here. Is it right? Okay? She added one of the box. In common approximate becomes 13. Okay, somebody tell me what do you understand by the term perimeter? Yes, what is perimeter? Okay, break down the number of the side. What else? Count the box. Observe the box. Okay, that is perimeter. Very good. Okay, if you got the number of boxes in that area, then what else? Yes, count the size of the figure. Okay, the total size. Yes.
You count already about the perimeter slide, then you add that.
So you know that for perimeter we count the size there, right? Okay. Now can you tell the class how do we find the perimeter? Okay, how do we do it? Can you explain to the class? Louder. Okay. Good. If we counted the side A, what is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is correct?
You see from the video, you can see that the teacher actually used the children's misconception, and he asked two questions to distill from them what do you understand by the word perimeter. And in the process, we also found that there are some who are quite confused with perimeter and area, and also opportunity to address this misconception. Right? At the same time, did not end there. The opportunity is given back to the child to self-correct, so that the child feel affirmed, and that now, although I made a mistake in the classroom, it's okay, and I am able to self-correct it. And those are actually the scaffolds given to the child. You can see the smile on the face, right? Yeah. This is one aspect of assessment for learning, right? In the teaching and learning method. mathematics. Okay, so in terms of assessment for learning, alright, it's about gathering information. And if the teacher is able to obtain information on what students know and think, as well as how they learn, the more we are empowered to be able to use more appropriate pedagogy, or use more or create opportunities to help our students to be successful, right? So the more information you have of what are your students, the way your students think, the way your students see mathematics, where they are, the more you are able to help them. So information is important, and we need the assessment for learning of assessment as learning to give us this information. So based on research from Left and William, their research, the effect size of using assessment for learning is very high, 0.4 to 0.7. But if we can use it well in our classroom, we can help our students, okay, to progress. Okay, I have another video to show you. This video was, have you all watched this video before in the intranet? It is already uploaded intranet. It's on evidence-based conversation in PLC. Now, because this project is anchored on a PLC setting, so therefore I thought it would be good for me to show this video. In this video, a team of teachers actually use class tests. Right? They analyze the class test. It's very summative, right? But you can turn it to a formative one. They analyze what is it that at a level, at a P5 level, what question is it that the students don't understand? And in the team, they go into collaborative inquiry. They talk about what is it that I want my students to learn, how they have taught it, and how could I move their learning forward. I did not go into the research lesson because it could be turned into a research lesson. That, okay, after this, how about one of you design the lesson and we're going to watch it now? Is what we said, is it effective? Yeah. So I don't want to share this with you to close the session to see how this sit in. That now we have assessment for learning, and we are using PLC. How does all these things tie in? Right?
In this video, a primary 5 mathematics learning team discusses students' understanding and expressing ratio of two given quantities. The conversation centers on students learning through the use of 4 critical questions.
Thank you everyone for being on time. At our last meeting, we discussed and came to consensus on what we want our students to learn about writing and interpreting ratio. Who would like to be the first to share your students' response to our lesson?
Learning teams clarify what they want the students to learn. The team earlier discussed the first critical question: what do we want our students to learn about the topic of ratio? In response to this question, we guide the learning team in their discussion.
Require the students to find the ratio of numbers passed in mark shapes facilitate the making of the formulas. Many of my students actually gave 1:2 instead of 1:3.
Compared to the questions, the students also face same here. Compared to the other questions, a significant number of students did the questions correct.
The
learning regularly. Meaningful data are collected and analyzed to serve as evidence to inquire deeply into students' understanding of what has been taught. The second critical question, how will we know if our students are learning, helps learning teams remain focused to ensure student understanding. Learning teams also ask the third and fourth critical questions. How will we respond when students don't learn? And how will we respond when students do learn?
These students compare the total number of stars to the total number of rectangles instead of the total number of shapes. I wonder why. Maybe they don't know what we mean by shapes.
But they have learned that shape in primary 1 and didn't have any difficulty understanding the term. Any other thoughts?
Let's go back to the learning objectives of the topic. One of the key learning objectives is that students are able to compare one quantity to the total number of quantities. I think we need to be more explicit in the instructions on this. So far, students only have examples that compare one quantity to the total number of quantities.
I thought they should have known that, shouldn't they? If they are asked for total, then they should add up the two quantities. Like what Mr. Lee said, we need to help our students be more aware of the two different situations in writing ratio, comparing one quantity to another quantity, and comparing one quantity to the total number of quantities. I use a simple method in class. I got 3 girls and 2 boys to stand in front of the class and I asked them this question. Question 1. What is the ratio of the number of girls to the number of boys? Question 2. What is the ratio of the number of boys to the number of girls? Question 3. What is the ratio of the number of girls to the total number of children? And lastly, what is the ratio of the number of boys to the total number of children?
I will try this out tomorrow and see whether the students have a better understanding.
How about those students who have already mastered this concept? How will we stretch their learning?
We can set a problem-posing task for them in which they will create their own word problem or writing ratio with 2 given quantities. They can then post these questions together with the solutions on an online forum for peer assessment. This will help strengthen their mathematical communication skills and deepen their understanding of the concept of ratio.
That sounds good. We should try this strategy for our students who have mastered the concept.
The third and fourth critical questions enable learning teams to come up with systematic and timely interventions to support students' learning. Students with difficulties in understanding content or concepts will receive additional support. Students who have learned will have their learning enriched. You have seen how a learning team focused on Big Idea 1, ensuring students learn, and Big Idea 3, focusing on students' outcomes. In Big Idea 1, team members made use of the 4 critical questions to guide their conversation and base their discussion on the evidence of students' work. We hope this video has provided you with a clearer picture of a learning team conversation.
Okay, so I hope this video give you an idea of what it will look like for your project. In your PLC, you have some discussion. Then, from the discussion, you can pick up whether we want to have a research lesson based on low progress learners, if let's say this is the situation, or we want to look at the one on peer assessment. So we can then zero in onto one aspect as the research lesson to further into how are the children responding to your teaching. So, okay, so much of that video. So now, before I end, we back to our chef. So when the cook tastes the soup, it's more formative, but when the guest, let's say this is a restaurant, right, then it is more summative. But in our teaching, we want our practice of assessment in the students' educational experience to be more like cooking rather than the tasting stage. So when we are teaching the lesson, we want to gather as much information as possible and address it. Timely intervention is very important. Because the moment they are learning, it's very difficult to unlearn and reteach. And one time consuming, right? So we are on to a very interesting journey to help each other grow and to be more assessment literate and to help our students in learning of mathematics. So this, I thank you very much.
So colleagues, I would like to thank Mrs. Seto for a very rich sharing, very usable points like voicing things that we use on a daily basis, voicing the